Good evening, everyone. Okay, so this is 1st September, and I'm doing a recording for TCS Nqt exam for the Ninja profile. Now, the exam is on 12th September, and this video recording is basically for students who can watch it on internet or online and prepare for the exam. Now, what happens with the TCS Nqt exam? There are three sections. They call it reasoning ability, verbal ability, and quantitative ability. Now, this video is specifically for the reasoning ability section. I call it logical reasoning. And what do we expect on logical reasoning for the NQT exam? There would be 30 questions which you have to do it in 50 minutes. Now, I'll tell you how this, what is the basis of this recording. Now, what I saw on the internet, what I did, I happened to see the sample questions given by TCS, and I happened to watch some of the sample videos as well on the internet. Now, what did I realize that the questions given as sample are basically very simple. And on the actual exam, the questions are, you can say, more difficult. So what I have done, I have taken those sample questions, kept the concept intact. So whatever the concept used is kept intact, and the new questions are designed which are slightly more difficult than those sample questions. So in order they should be matching the exact difficulty level what is expected on the exam. So this video is for logical reasoning, and I would be discussing about 12 questions in it. And similarly, I'll make a video for other sections as well. Okay, so hope you enjoy the video. Okay, so idea with the video session would be like there's a question given. So I would expect, I hope that students pause the video for some time, have a look at the question, try to do on their own. It would nothing like it if you do it on your own. So that's going to be the best. Now, otherwise as well, we are definitely going to discuss it here in this video lecture. Now, if I happen to look at the first question is on, you can say, coding, decoding, and what does it talk about? So if I read it, it says in a certain code. Okay, so there is a code. If Trivandrum is coded as something like this, okay. So how is Jamshedpur written in this code? Now, I'll tell you what is the point of deception over here. Every exam comes up with the question maker comes up with the kind of a deception. They want to deceive us. Now, what is given in this question is if you try to match, let's say, all the alphabets sequentially. Let's say if I assume that the code for T should be O and then R should be E, I'm going in sequence, I would realize that they are not matching. So this kind of working is not going to work over here for this kind of a question. So I have to think some other way around. Now, what is this some other way around? Can I have a look at it? I write it down. I have this Trivandrum over here. Now, what do I realize with the word Trivandrum is something very peculiar with Trivandrum would be it has two R's in its, as in it is spelled with two R's. So if I'm writing the code and the code would for R would remain same, so I would have two alphabets which would be same again. So if I happen to look at the code, I happen to realize it has two S. So what does it basically mean? It means R was coded as S over here. Now R was coded as S would mean simply it is like you read the alphabets like P, Q, R, S. So it is like you add 1 to it with the position value and you arrive to S. Okay. So but then it was done like this, that R was coded with S and thereafter T would have been coded like P, Q, R, S, T, U. So it would be coded with U. Okay. But then it was not written sequentially. It was written in a way that the sequence is not followed. Okay. So thereby this code appears to be, you can say, kind of a, you can say, it's not easy to comprehend that way sequentially. So, but what I realize now that every alphabet with Jamshedpur is also going to be increased by one position, and then the resulting code is going to be like, it's not going to be arranged sequentially. But what does it mean? All the alphabets, if I increase it by one with the position value, should be there with my answer choice. So if I have a look at Jamshedpur, I happen to write Jamshedpur over here. So if I increase it by one, so it should be coded as K, A should be coded as B, M should be coded as N, S should be coded as T, H should become I, E should be F, D should be E, and P should be Q, U should be V, R should be S. Okay. So now with this, I have a kind of a code I have the code. Now the alphabets are going to be like, they are not arranged sequentially. Now it's going to be little, you can at this point of time see, okay, do I have to check all of them? But it is going to offer something for us. Let's say I happen to look at Jamshedpur certainly has A and B is over there, but certainly it does not have a B. Otherwise C would have been in my answer choice. So C should not be there in my answer choice. If I happen to look at the first, quickly I can realize that there is a C. So I can rule out the first answer choice. It is not matching. Now, if I happen to look at the second option, and if I happen to realize, do Jamshedpur has an I in it? No. So thereby, if I increase I by 1, I would be getting a J, but that should not be in my answer choice because Jamshedpur do not have a I. So I can rule out the second option as well because it was having this J. Okay. Now, when I happen to look at C option, so I quickly realize that it is having a W. Now, if I look at my code over here, it does not have a W, so I can rule this out as well. The moment I eliminated 3 answer choices, the fourth one has to be my answer. So nothing much in the first question. The code was very simple. You were just increasing it by 1, but then at the same time, you were not following a sequence. So that was the point of deception, you can say. Okay, second question. Second question is based on sitting arrangement. A very common question. You get it on logical reasoning all the time. So please, I'll read it once. It says 6 person A, B, C, D, F sit 3 in each 2 rows which face each other. So they happen to be like 6 people and they were seated in 2 rows and they face each other. Now, if they face each other, what does it mean? These people should be looking in this direction and these people should be looking in the opposite direction like this. Okay. Now, it says the point we need to keep in mind over here, which is important, is because the question will talk about people sitting on the right or people sitting on the left. So the moment I happen to get this direction in place, I need to clarify one thing and I need to remember this thing for myself, that here the right would be on this side and for these, and the left has to be on this side. For the people who are facing opposite, you can see, try to visualize the left is on this side and the right has to be on this end. Okay. Now, once we are through with this direction, now we start reading the clues. Okay. So I can draw it here as well for my reference. So if I happen to read the first clue, it says E is not at any end. Fair enough. E is not at any end would mean I can keep E over here. Or I can draw it like this as well and I can keep E over here. Now, the next clue. D is sitting second to the left of F. So I don't know where F is. But let's say if F happens to be over here, then what do I know? The left is on this side for these set of people. So D has to be then second to the left would mean D has to be over here. Now, but with this kind of a thing, I can also draw this kind of a configuration, as in I could have considered E to be over here and F over here and D over here. Okay. Or I could have gone the other way around, as in I could have also let F be seated in this row, as in this row I'm talking about. Okay. So if F is sitting over here, so F is going to be over here, and D is second to the left, so D has to be then over here. And another kind of a possibility I can chalk out is E over here and F and D over there. Everything is possible. Now at this point of time, you would have said, okay, why am I making so many possibilities? Now we could have also thought about it and go in for less number of choices, but as a kind of a discussion I'm showing you over here. Okay. And don't worry, moreover, when you try to match up with other clues, or like out of 4, 3 will not be following all the clues and they will certainly vanish, they will certainly disappear, and only one is going to be left over, which is going to be our answer. Okay. So I happen to read the next clue. C is the neighbor of E and is sitting diagonally opposite of to D. C is a neighbor of E and is sitting diagonally opposite to D. So I can have it over here. And C is, you can see if I just draw a line over here, C is neighbor of E. So it is not possible with this kind of a configuration. So this is out already. And again, it is out over here as well. And if I happen to look at it here, C is a neighbor of E and has to be diagonally opposite over D. So that's going to be correct over here as well. The next they say B is a neighbor of F. B is a neighbor of F. Over here would be B, putting B over here, and again putting B over here. Now what is the question? They were saying who is opposite to B? Who is opposite to B? It has to be E all the time. Whether it is this possibility or this possibility, both the possibilities are okay. My answer has to be E. That is the B option. So nothing much in this question. I would say certainly we need to figure out, we need to keep this thing in mind that when people are sitting facing each other, I need to ascertain what is to the right and what is to the left. And then there is only one thing with the sitting arrangement questions is, guys, please don't take a shortcut. Please follow all the clues and then only arrive to the answer. Okay. Now, then this is an interesting one. This third question is kind of interesting. If again, I'm reminding you, okay, the idea with this kind of an exercise over here with this video lecture is also, please pause the video, do the question on your own, and if then later on you can match up your answer with our answer. Okay. Now have a look at this question. What does it say? It says Alex says, I have as many sisters as brothers. Okay. So this is, I'll tell you, this is an equation making question. Very simple, but yes, it comes up with twists and turns. It says Alex says, I have as many sisters as brothers. So one thing towards the end, if I read it, it also talks about if Alex and Miriam are brother and sister respectively. So I happen to know the gender of Alex. Alex happens to be brother. So Alex is a male member. Okay, so there are few males and there are few females and they happen to be brothers and sisters. And what does it talk about? I'll read the first sentence again. I have as many sisters as brothers. So let's say they were like n male members, I can say. And this one was Alex. Okay. So once this one is Alex, what is the leftover? You are left over with Alex would have n minus 1 brothers. Okay. Now, the first sentence says, I have as many sisters as brothers. So one thing is there, sisters all are Alex's sister by this in this question. So how many sisters Alex have? As many brothers. So it has to be 9 minus 1. And towards the end, which makes the female are in number n minus 1. Okay. So there are n minus 1 females and there are n males. Okay. Now, read the second sentence, which Miriam says. Miriam says, each of us sisters has only half as many sisters as brothers. Each of us sisters has only half as many sisters as brothers. Each of us sisters, you can say, Miriam is saying, each of us, as in a sister, has only half as many sisters as brothers. Sisters would be, if let's say this lady is Miriam, so sisters with Miriam would be n minus 2. N minus 1 are the total females, so n minus 2 has to be Miriam's sister. And if you put it in the sentence, each of our sisters has only half as many as brothers. So half as many as brothers over here would mean n by 2. Brothers would be n. So how many? N by 2. So if you solve it, it is going to be 2n minus 4 is going to be n. And if you bring n on one side, n will come out as 4. Now if n comes out to be 4, so n the value is 4. N minus 1 the value has to be 3. So towards the end, if you want to count how many brothers and sisters are there, so there would be 4 brothers and 3 sisters. I hope this is clear. Once again, if you look back at the question, so the question is very simple and it is based on a very basic idea. That the basic idea is you're just making two equations, very simple ones. The only thing is you need to read the question very correctly. Okay, that's what is required. Okay, then there is logical reasoning and you would get a sequence of code. It has to be there. Okay, let's see what is there. I write the code on my own. Let's say I happen to write it like this. This is the first term. Second term is left question mark, which we need to figure out what is it. And the next is R64P. Let me write it correctly. P125S and N216V. Okay, this is it. Okay, fair enough. Now, what is it if I happen to look at the codes? Before we start with something, this is if let's say some of us would have done a question of this sort and some of us might not have done it. So what is in it? You basically figure out you have to deal with three sequences. There is an alphabet and there is a number, a digit and number, and then there is a alphabet once again. So three sequences you are dealing with. So let's say if I try to look at the number 8 and if I try to look at what is 64, 125 and 216, I happen to realize one thing. This is 8, 64, 125 and 216. What can I recollect from it? This is 2 cube and this is 4 cube and this is 5 cube and this is 6 cube. So if I need to fill the leftover place, you would agree with me, for numbers it has to be 3 cube, which is 27. That was it. But so 27, the moment I get 27, I can get rid of these two options, but again C and D are definitely over there. Now I happen to look at this. This is V. Before I start off with V, I need to recollect that how the questions are based. On alphabet series, alphabet coding, what happens is the coding is basically done with regards to the position value. So let me quickly write it once. I know all of you know it, but just for the sake of discussion, I am writing it again. Okay, so these are how alphabets look like. So one thing we need to remember over here and be focused for this, just remember E, J, O, T, Y. So the position of E is 5, J is 10, and O is 15, and T is 20, and Y is 25. Nothing much, but what happens is, if you remember this, I know all of you would be remembering it, and I'm just doing it as per the discussion. Then the thing is, to get the position value of other alphabets becomes easy. As in D would be 4. I can quickly say what is G. G is going to be 7. Okay. So if I happen to look at V, where is V? V is 22. Okay. So V is 22 over here. And I don't know what is over here. And what is about R? What about R? R is, you can see it's 18. Okay. So there is an 18. And if I happen to look at P, P is 16. Okay. So it is going like 18 and a 16. And what is the next n? N is, you can very well see it's 14. So what is happening? We can ascertain it now that it started like a 22 and there must be a 20 over here, and then it is going to become an 18 and 16 and 14 and so on. So 20 is going to be, you can see very well, T20 is T. So I should be getting in my answer, I should be getting a T over here. So my answer looks like this at the moment, T27. But it changed nothing much because both C and D options have T in it. And things would be finalized once I need to check whether it's an N or an M over here. Okay. So if I look at J, where is J? J is 10. Okay, fair enough. I'm looking for the third sequence now. And I don't know what is over here, but what is P? P you can see is 16. Okay, fair enough. And what is S? S is, you can say it is 19. And then V is 22. So what do I see over here? There is a 22 and then it was a 19 over here and then a 16, 16, 19, 22. So it is going at a gap of 3. So it should be a 13 over here and it would continue like 10, 13, 16, 19 and 22. So 13 would mean if I try to figure out what is going to be 13, 13 is going to be M. So my answer has to be this, that is the D option. I can get rid of the C option now. Okay. Okay, so the next question is on series. So if I happen to write the terms over here, the terms are 18, 10, 11.5, and 19.25. Okay, so it is getting a bit complex in decimals, and then it is a 41, and we need to figure out the next term. Okay, so if I happen to look at the terms over here, so what do I realize? First of all, it started with 18, there was a decrease, it became 10, and then there was a slight increase from 10 to, it just not jumped somewhere, it was slightly like just an increase of 1.5, and then slight increase again and an increase again. But what do I need to work on with this thing is, as in for the operations used, there is a decrease and then followed by an increase. Now, if there is a decrease and then it is followed by an increase, certainly it cannot happen with the, you can say only if like addition or subtraction is done. No, it cannot happen. So certainly it is possible only with like multiplication or division, which is like both are analogous. If you, let's say, divide it by 2 or you multiply with a half, it means the same thing. Okay. So I happen to, keeping this thing in mind, if I happen to look at the first term, which is 18, and I need to arrive at 10. From 18, I need to come to 10. So I know 18 into half. So I can say if I multiply this thing with 0.5, it is going to become a 9. But suddenly I need to add a 1 to it to make it a 10. Now I'm just trying it out. I'm just trying it out. If it works, fine. If it does not work, I'll try something out. I try something else. I'll try something else. Okay. From 10, I need to go to 11.5. So certainly 10 into, you would have said, if you multiply with the 1, it would have remained 10. Now you need to add a 1.5 to it. So I am basing my idea on that I multiplied with the 0.5, then I multiplied with the 1, and I needed added a 1 over here and a 1.5 over there. So if things are going fine with this trend, next time I'm going to multiply with, let's say, 1.5, and next time I'm going to add a 2 to it. So if I do 11.5 into 1.5, so 11.5 into 1.5 would mean 11.5 into 1 would be 11.5, and half of it would be like 5.75. So if I add 5.75 to 11.5, I'll be getting 17.25. If I add a 2 to it, I'll get 19.25. So yes, it is working. And once it is working, there's a kind of a confidence going with me now. So I certainly would multiply. The next in line would be, I had been multiplying with 0.5, 1, 1.5. So I'll do it with a 2. and I add a 2.5 to it. So once I do it, you can say 19.25 into 2 would be giving me 38.5. I add a 2.5, so that would be 39 and 2, 41. So it is working fine. So next, as for the answer, I would multiply with 2.5 and add a 3 to it. So if I'm doing it, 41 into 2 would be 82. That's part of the things. And 41 into, you can say, half or 0.5 would be 20.5. So that should be 102.5. I need to add 3 more to it. So that should be 105.5. And that is going to be my answer over here. Okay. Okay, so this is something interesting. Interesting in the sense because many of us would not have seen a question of this sort. Uh, might be possible if you are practicing, it is okay. But let's say at times for some of us it is quite new. Otherwise, the question is simple, but you can say its novelty, its newness is, let's say, we need to work on. Okay. So what is given? X by y plus z is going to be 6. Okay, this is what has been said. Where x, y, z are distinct, okay, make sure of the words, they are distinct positive digits. Okay, so they are distinct and positive digits. Distinct positive digits. Positive is 0 positive? No, it is a digit, but it is not positive. It has to be positive digit. We start with 1, and digits are going to be like they're 9. If I omit a 0, so these are going to be my digits. Okay, so they have to be, for xyz, they have to be distinct, and my set from which they need to come is like this. Okay, and they should sum up to 6 like this. Okay, fair enough. So certainly you would agree with me, if I happen to choose 1, if I divide by any of the other digits, it is going to be a fraction. And if you add a fraction to some integer, it is not going to be an integer. For this thing, it has to be, this has to be separately an integer, and again this has to be separately an integer, then only you'll get an integer when you're dealing with z to be integer. Okay, so this I need to keep in mind, and this is going to be useful for us. So 1 with 1, it is not going to work, and keeping x to be 1, I meant like this. So can I keep x to be 2? Let me see. 2 by, I could have written y to be 1, so that would be 2. And if I take z to be 4, yes, it do work. Fine. So this can be one of the answers. There is one thing I need to also consider, z should be more than y. So is z more than y over here? Certainly it is more. Now, fine, it worked for 2, for x being 2. X being 2, I cannot choose these because then it is going to be fractions, so it is not going to work. So then I go for x being, I can write x was 2, x being 3. That's how I'm checking. So if x is 3, I'll say okay, 3 by 1, then I need to add a 3 to make it a 6, but then the digits are not distinct, it is not going to work. For x being 3, I can also, can I do with 3 by 2? No, it is not going to work. 3 is a prime number, so if you divide it by something other than 1, it is going to be a fraction. It is not going to work like this. So I'm done with 3 as well. I can try with x being 4. If x is a 4, I can do 4 by 1 plus 2. Yes, they are distinct. Z is more than y. This can be y, another answer. Now, if let's say, if I say it is 4, if I take it to be 2 and add a 2, it is like they are not distinct. It is not going to work. With 4 by 3, it is not going to work. Now, my next thing would be when x is, let's say, 5. If x is 5. Now, if x is 5, I can try with 5 by 1, but then a plus 1 would make it same. So it is, the digits are not going to be distinct. So I am not writing it. 5 by 4, 5 by 2, 5 by 3, all would be like it is not going to work. So it is not going to work for x equal to 5. Now x equal to 6. If I take x equal to 6, I can say x is a 6 by 1 plus, now it is going to be a 6. So it has to be a 0. So it is not working. x being 6, and if I divide it, let's say, by 2, and I add a 3, it works. It is one of the solutions. That's fine. Now x by 3, if I do 6 by 3, you need to add a 3, so their digits won't be distinct, so let's not write it. I move to 7. I check it for 7. Once I check it for 7, 7 says 7 by 1. No, it is not going to work. And then it is all going to be prime numbers is a 7. So it is, if I divide by something which is not 1, it is going to be a fraction. So it is not going to work altogether. X being 8. If I take x to be 8, I'll say 8 by 2 is 4. And I add a 2. No, it is not going to work. They are going to be same. 8 by 4, 8 by 2, sorry. The last time 8 by 4 is going to be a 2, and I need to add a 4 to it. This is also not going to work. And then 8 by 6, I cannot take it to be. 8 by 7, 8 by 5, I cannot. I go in for the last choice, x being 9. Now, if x is 9, I say, okay, 9 by 1, no, it is not, it's going to be more than 6. 9 by 3 plus 3, it is not going to work. 9 by 4 is not that, here the digits are not distinct. 9 by 4 is not going to work. 9 by 5, 9 by 6, should I try? No, again, it's going to be a fraction. So it is not going to work. So how many options do I have for the answer? I got this one as an answer. I got this one as an answer. I got this one to be my answer. And was Z more than Y all the time? Yes, Z was more than Y, Z was more than Y, and Z was more than Y. So that has to be 3 then. Okay. Okay, so this is really interesting question, and you are definitely going to get it for logical reasoning. Such questions are always going to be there. So let's have a look at this. What does it talk about? It says Shweta, her brother, her daughter, and her son are playing badminton. Okay, there are 4 people playing doubles match. And what is the condition given? Shweta's brother is standing opposite to her daughter. Okay, so let's try to make it. So we try to make a badminton court like this. Now, Shweta's brother is standing opposite to her daughter. So this is where the brother is, and then this is where daughter is, Shweta's. Okay. Now, what else is given? It says the worst player sibling is standing diagonally opposite to her son. The best and worst player are on the same side. Now, with this thing in mind, that brother and daughter Shweta's are like sitting, standing opposite, I have 2 places left over here. This is 1 and 2. Now, with these 2 places left over, what can be the possibility? The possibility can be son can be over here and Shweta herself can be over here, or it can be the other way around. It can be the other way around would mean brother over here, daughter over here, and Shweta over here, and son over here. Now, if this is the case, let's have a look at it. You would say, okay, let's go with the things. If I read the second clue once again, worst place, sibling is standing opposite to her son. So who is opposite, diagonally opposite? Daughter. So that would mean if it's diagonally opposite to son is Shweta's daughter, and it has to be the worst player sibling is standing diagonally opposite, so son would become the worst player then. And since by the third clue best and worst are on the same side, brother would become best player. Okay, in this. Now if I try to figure out the next one, you can have a look at this. It says brother is, okay, let's have a look at son. It says the worst player sibling is standing, okay, so who's standing diagonally opposite to son? Brother. And brother would be like, that means the worst player sibling. So that would mean Shweta is the worst player then. And worst and best are on one side. So that means brother is still the best. So both the possibilities, the brother has to be the best player. Okay, so that is going to be our answer. Okay, so there's kind of a question we did before as well, but this is back here as well. Such questions are always there for the logical reasoning section. So before we start off, I can write the alphabets once again, just for the reference. I know this is, you need to be good with them so that you can quickly spot the position value. And this is for mere discussion, I'm writing it over here. Okay, so the first one says LG19. So I'm writing the terms LG19 and OI24. This is what I need to figure out. The next is UQ38 and the next is XX48. So the moment I happen to see this 2x and 48, I happen to realize one thing. X, the position value is 24. So this 24, and might be possible this is 2 times of it, or they sum up to 48. So keeping this thing in mind, I happen to look at U and Q as well. So what is U? U is, you can say 21. And what is Q? Q is, you can say this is 17. So this sums up to 38. So that is how things are moving here. Okay. OI, what happens with O is 15 and where is I is 9. So they are summing up like this. And what is LL is 12 and where is G is 7. So they are summing up to 19. So the only thing we need to realize is we will be getting the sum over here as the number, but we need to ascertain what is the pattern going on with alphabets. So if I check this one out first, 12 and followed by a 15, we need to figure out, and then it is a 21 and a 24. Okay, so 21 and a 24 would mean there is a difference of 3, and 12 and 15 there is a difference of 3, so this has to be 18. Nothing much over there. 18 would mean, as in with an alphabet, it is going to be R. Okay, so R, but all of them are R, so it did not help much, but okay, let's say this is a start. So happen to look at the next one. This is like, it moves like a 7 and a 9. I need to figure out for this, and then a 17 and a 24. 17 and a 24, there is a difference of 7. And 7 and 9, there is a difference of, you can say, there's a difference of 2. So there is a difference of 2, and then there is a difference of here there is a difference of 2. Something was added which came up here, and then it is 17. Okay, 7 over here is not going to be a kind of a match with, let's say, ordinary. If I go with like a 2 and a 4 or something, it is not going to match. I have to think beyond it. Beyond it would be, can I think in terms of, you can say, prime numbers, where the gapping is with regards to prime numbers. So 2, there is a gap of 2. If I go with the 2 is one of the prime numbers, smallest, and then there is a gap of 3, which is the next prime number. So if I assume it to be a 12 over here, I'm just assuming, then it should be a gap of 5. Then it should be a gap of, there is a gap of 2, and then there is a gap of 3, and then there is a gap of 5. Yes, it is working fine, and then there is a gap of 7. So it is a gap of 3, which is a gap of 3 would mean 9 and a 12. So R was this, and 12 would mean R was 18, and 12 a gap would mean 12 would be L. So L would be over here, which is a 12, and I need to sum them up. So it has to give me 30 over here. RL 30, that should be my answer. So it has to be this B option. Okay. Now this is again a very interesting question, which I happen to see it on the internet as well. It has been changed. So what is it? It talks about there has to be like you need to infer something over here. So what is given? I'll read it. Two of ABC are playing chess with each other. So there are three people, ABC, and among the three, two are playing chess. Now, few facts have been given. What does it talk about? The taller of A and C is the younger of the two players. Okay, fair enough. So I happen to read all the facts over here and then I need to infer something. Okay. So let me read it once again. So this is a very nice question, I would say. Initially, you can find it somewhat, so some of us it is going to be challenging, and though it is based on a very simple idea, but we need to precisely get to that idea. That is where that inference would start. What does it talk about? If you happen to look at the first thing, taller of A and C is the younger of the two players. So whosoever is taller, from the first I can infer whosoever is taller between A and C, is the younger player. So can I infer it like this? The younger player has to be between A and C. It cannot be B. B is not the younger player. I believe it is okay, guys. Please have a look at it. I'm saying A and C, between A and C, it has to be the younger player, has to be between A and C. So what is the inference I can draw? B is not the younger player. So if I happen to look at the inferences, it says one of the options says B is the younger player. So what am I inferring? B is not the younger player. So I can strike this off. Now if I read the third one, it says the younger of B and C is the shorter of the two players. Younger, whosoever was younger between B and C, it is between B and C, is the shorter. So the I can say shorter is between a B and C. So using the same logic, A cannot be shorter because the shorter player has to be between them. A cannot be shorter. So A is the shorter player. This is the third option. So I can rule this out as well. Now the third I read, shorter of A and B is the older of the two. Whosoever is shorter between A and B is older. So certainly older player has to be between A and B, and with the same logic, C cannot be older. C cannot be the older player. C cannot be older player means, okay, this is where this inference is written. B option, C is the older player, not the older player. And this is what we are getting. C is not the older player. So that has to be my answer. Once I get my answer, D makes no sense. Okay. Once again, I would like to put it back. So this is a very interesting kind of a question asked by TCS. I would say a similar question is given in this sample, but this is a slightly better than that. But yes, you need to figure out the inference by reading it precisely. That's the intention. Okay, so back to the old things, back to C-logs. So C-logs, we know, everyone knows what is it. So this is, I'm not reading it. So I quickly go to the statements and I need to go for the conclusions. So if I read the statement, it says some rivers are mountains. Some rivers are mountains. How do we draw it? Rivers and mountains, we draw intersection. We go with the minimum overlap diagram. So rivers and mountains, they do intersect. That is what means some rivers are mountains. Okay. Then it says all mountains are plateaus. So I can cover all mountains are plateaus. So I can cover mountains inside plateaus. And then it says no plateau is a sea. No plateau is a sea. So sea should be like disjoint to plateaus. And then I read the last one, some seas are rivers. So some seas are rivers. So I can make seas like this. And you can see they are disjoint as well to plateaus. So this is one of the diagrams I can draw. This is the minimum overlap diagram. Now based on this, I need to conclude. So if I look at the first conclusion, it says some rivers which are plateaus are not seas. Some rivers which are plateaus. So you're talking about the intersection common area between rivers and plateaus. They are not sea. So some of them are not sea. some rivers which are plateaus. So rivers which are plateaus, and plateaus are certainly not sea. So they are not seas. So that has to be correct. That's correct. Now, if you read the second, it says some plateaus are not rivers. Some plateaus are not rivers. So it talks about plateaus which are outside rivers. So this is the area you are referring to. So with this diagram, it seems to be okay. But I need to check it with other diagrams as well, if it can be drawn. The idea with the second one here is the plateaus and rivers. Plateaus, a part of plateau should be outside river. It should not be enclosed in river. Now, if it is enclosed in river, I cannot conclude this second part. So I'll try to make a diagram wherein can I enclose plateaus inside rivers. So I draw it again. Some rivers are mountains, so I try to draw it over here. Some rivers are mountains. Some rivers are mountains, so I can draw mountains inside rivers as well. It do not, it is still validating. Okay, validated. All mountains are plateaus, so I can cover all mountains, plateaus like this, and no plateau is a sea. And some seas are rivers, so I can conclude, I can make it like this. Now, when you come to this and you read the second conclusion once again, some plateaus are not river. Here, all plateaus are rivers. So some plateaus are not rivers. It is not going to be true with this diagram. And since it is not true, I cannot say this is a possibility, but I cannot conclude it entirely. So I need to reject it. So my answer has to be only one conclusion, one follows. Okay. Okay, so this is something new. Once again, this is a diagram they are referring to. Okay, so it says find the number of triangles, and you would be amazed there is only one triangle. So I need to, in this video, I need to make the diagram completely. So they were like, what they did with this question over here is they make 4 points over here. And when they made a 4 points over there, they connected it like this. Okay. And then they make a connection like this till here, and then they make a connection till here. Okay. And now you need to find the number of triangles. Okay. So what is there in this question is I'm going to, like, some of you might be knowing it, but then for others, I would be telling you a small, you can say a technique, which is based on a very simple logic, and we need to look at the logic as well. And then we'll come back and answer this question. So let's say I take a simpler figure for the start. Let's say it was joined like this, and I need to find the number of triangles over here. So I can label it like this: A, B, C, D, E. Okay, this is how it is labeled. And now let's have a look at it. I need to count the triangle. So you would agree with me, I can start counting the smaller ones like ABC, which is, you can say the base of it is like 1/3 of the entire base. And then I can count ACD, which is having the same length of the base, and then ADE. How many are there? There are 3. Then I can also take the base to be like 2/3 of the entire base. I can count such triangles to be like ABD, and then I can count it like ACE as well. You would agree. These are going to be 2 in number. And then finally, I take it to be this as a larger triangle, BE as the base, and then there is going to be one triangle, ABE. So if I needed to count them, this is going to be like the number of triangles would be 1 plus 2 plus 3, which is going to be 6. Now, but what is more important than 6 is, can I do it in a kind of a shortcut? This is a process. Now, this is going to be replicated. Once again, if you increase, let's say, one more point over here, you call it X. Now there are 4 divisions on the base. You would realize my answer would look like 1 plus 2 plus 3 plus 4. So basically what has to be done, the number of divisions on the base, and you need to start with 1 and count like 1, 2, 3, 4. As in, that is like 1, 2, this is the second, this is the fourth, this is like for the 4 smaller ones. And then it is going to be, when you start combining, then it is going to be a 3 and a 2 and a 1. So the moment you count the number of divisions on the base, that is, you take the summation till that number, that natural number, that is going to be my number of triangles. So coming back over here, if I want to count the number of triangles, the base had 4. So I would have said, okay, the triangles for the base would have been, you can say, when you are counting, we are not taking, we are not including this line. I'm talking about this line and this line. So then the triangles would have been 4, like 1 plus 2 plus 3 plus 4. That is going to be 10. Now, when you talk about this triangle specifically, again, how many divisions the base is divided? The base is divided into 3 divisions. So number of triangles, when you start counting, it is going to be 1 plus 2 plus 3. So that should be 6. And same will happen over here. When you count it, it is going to be, the base has 3 divisions. So it is going to be 1 plus 2 plus 3. So I'll get 6. Towards the end, what is my final answer? My final answer has to be 22, which is going to be this option, answer option. Okay, so now what we have over here as the last question, it's a dice question. Okay, it's a die question. You call it, singular is die and plural is a dice, pair of dice. So if you read it, the given fair die. Okay, so what is a fair die? Let's talk about it like this. So with a fair die, the sum of the numbers on opposite phases will sum up to 7. As in 1 and 6 will be opposite. They will be summing to 7. And then it is going to be like 2 and 5 are going to be opposite. They will be summing up to 7. And 3 and 4 are going to be opposite. They're going to be summing up to 7. So what is the idea with calling it a fair die? So the moment you happen to see 3 numbers over here, what you know, as in like opposite to 3 would be 4, and opposite to 5 would be 2, and opposite to 1, that is 1 is on the top, so 6 has to be on the bottom with this question over here. So now the idea over here with this kind of a question is, it says it is rotated, one step to the right. Let's read it. It is rotated like 1 step to the right and then moves 1 step forward. Which number will appear on the top face? So first it moves towards right. So when it goes towards right, you can say, okay, if you try to move it to the right, this face would remain as it is. So this face 3 would remain as it is. But what will happen with this face on the top face 1, where this 1 is written? So 1, it is going to be coming in place of 5. Okay, so now it is going to be replaced by 1. And over here, we know opposite of 1, it is going to be 6 over here now, because it's a fair die. Okay, and what will happen to this 5? The 5 is going to go towards the bottom. And when it goes towards the bottom, what will come up on the top face? It has to be a 2. So towards the first motion, which is onto the right, we see that 2 has come on the top face, and 3 is the face which is facing us, and 1 is on the right. Let me write this one over here. Okay, so this is how it is going to look like after it has make one transition, and that was towards the right. Now it is going to make a forward transition. So what will happen on the forward transition? This, you would agree, this 1 would remain as it is, and this 3 is going to go on this. It is going to roll like this. So 3 is going to come on the top face, and that solves our question. So what is going to be on the top face? You say it is going to be 3, which is going to be our answer. So what else? Thank you for watching the video. I'll be recording other sections for TCS Nqt as well soon. Hope you enjoy the video, and please go through the questions. And if there is a concern, please do let me know. But yes, more importantly, please pause the question, do it on your own first, and then only compare it with the answer. Okay, so best of luck for TCS Nqt, and hope you enjoyed the video.